Hello and welcome to this video on scatter graphs. So we're going to be looking at quite a lot of skills actually in today's video. So we're going to be looking at how to describe scatter graphs using the relevant key terminology. We're going to be looking at how you would plot data on a scatter graph, drawing a line of best fit on one, and then how you would interpret the data from a scatter graph. Okay, so let's have a look at this example of a scatter graph then. So a scatter graph is essentially there to show whether there's a relationship between two sets of numerical data. So on this example here, we can see that when the temperature's warmer, we get more visitors to the beach. Right, first important bit of terminology here is this word correlation. So correlation is another way of saying pattern. And that's what a scatter graph is trying to essentially show you. So we've got three types of correlation here. We've got a positive correlation, so that's where you've got both pieces of data increasing, as we can see with X and Y, they're both increasing there. Then we've got a negative correlation, so that's where one piece of data is increasing but the other is decreasing. So on the example that you've got in the middle there, X is increasing but Y is decreasing. And then you've got at the end there no correlation. So if you get a scatter graph like this, there's no link, there's no real pattern between those pieces of numerical data. Next bit of key terminology here is this line of best fit. So when you've plotted data on a scatter graph, you may need to draw a line of best fit, and that's to sort of show the rough pattern essentially. So the aim when you are drawing a line of best fit is to try and get it as close as possible to the data. It's got to be a straight line, so you don't join up your dots or your crosses. The aim is to try and get it as close as possible to the pattern, because then you are able to use it, as we'll see shortly, to be able to figure out some data from the scatter graph. Okay, now we're going to have a look at actually drawing lines of best fit and looking at how we can interpret the data from scatter graphs.
Right, so let's take a look at this example then. So this scatter graph shows the scores of 16 students on their biology and physics test. First question is, what type of correlation does this scatter graph show? Well, we can see that as the biology scores get higher, the physics scores also get higher, so that's going to be a positive correlation. Right, and then this is a very typical scatter graph question here. So we've got another student scores 52 marks on the biology test, and it says estimate the physics score for this student. Okay, so what it's always quite good to do is have a look at what one little small square is worth on the scatter graph. So if we take a look at this here, we've got 10 squares between 0 and 20. So if we do 20 divided by 10, that gives us 2. So every small square is worth 2 marks on this side, and it's also worth the same on the physics side as well. Now, to be able to do this estimate, we need to draw what's known as a line of best fit, which I've already mentioned earlier in the video. So to do that, we basically need to try and draw a line that roughly follows the pattern. And when they're all sort of spread out a little bit like this, when it's not a strong correlation, you've got to sort of try and get it as close as you possibly can to this pattern. Okay. So let's see. Let's try and get it as accurate as I can. Let's see. I think probably about there would be okay. Okay, when you've got your line of best fit, you need to go to the piece of data it's given you. So we're being told that this person's got a score of 52 on the biology test. So you draw a line up to your line of best fit, and then where you hit it, you move across until you hit the other axes, the y-axis in this case. So we can see we're going up from 52, we're hitting the line at roughly 64 on the physics test there. They will usually give you a little bit of leeway, so I would imagine with this one, probably anywhere between 62 and 66 would have been accepted for this particular answer. Right, so on this question then, we've got a slightly different correlation here. So this question's saying that Gary recorded how many goals that 10 football teams scored. He also recorded how many goals they conceded, and this is shown on a scatter graph. And we've been asked what is the correlation here, and we can see it's a negative correlation, and the reason for that is because when a team is, the general pattern here is that when a team is conceding more goals, they're scoring less goals as well. Okay. So then we've got a line of best fit question here. It says another team have scored 44 goals. Estimate the number of goals this team has conceded. So we need to draw our line of best fit here to do this. So again, we need to fit the pattern as accurately as we can. So there's your line of best fit. So we're looking at goals scored here, and we can see there are 10 squares between 20 and 30. It's a nice easy scale here really. Every square is worth 1 goal. So if we go four squares up from 44. On this side, we go across until we hit our line of best fit, and then we need to go down until we hit our x-axis. So we can see here we should have 41 goals based on this. They probably would allow a reasonable range on this sort of question, probably from about 40 to 44 maybe, depending on where your line is. So there's going to be a slight a bit of flexibility when it comes to drawing your line.